Metabolism, we know that it's what causes us to gain weight or to lose weight. For example, you might have a fast metabolism, and you can pretty much eat anything you want and not gain weight. You know, those people. Or you might have a slow metabolism, which generally means that if you just look at a piece of cake, you're going to gain a couple of pounds, guaranteed. So not fair. But our metabolism is actually so much more than gaining and losing weight. It's also tied to how your body makes energy in your cells on a minute-by-minute basis. Now today I'm going to share with you some recent discoveries that scientists have made about how our metabolism works. And if you're currently struggling with a metabolic disease like cancer, diabetes, or chronic fatigue, this information can absolutely change your health, and it might even save your life. Now, if you aren't sick, the information can help you stay well and vibrant for the rest of your life. Recently, you may have heard a lot about your mitochondria. It's sometimes also referred to as the powerhouses inside your cells. It's the place where your body actually makes energy. Now, your mitochondria is responsible for making the energy that your body needs in order to do things that you are aware of, like driving your car, going out dancing with your friends, or balancing your checkbook. But the mitochondria in your cells also makes energy for the things that you aren't so much aware of, the autonomic, or as I like to say, the automatic functions of your body, like digesting your food, breathing air, building muscles, and fighting disease if you happen to get sick. But in order for you to make energy with this miraculous process, your body must take the hydrogen from the food that you eat and combine it with the oxygen from the air that you breathe, and then feed those two elements into these things called nanomotors that live in your mitochondria. And presto, out comes the energy that powers your body. Now, you might remember this process from your high school chemistry class. It's called the Krebs cycle, and this is the process by which your body makes ATP. This process is nothing new. In fact, biochemists have known about this process for a very long time. We knew that it worked, but we didn't really know exactly how it worked until very recently. It seemed that the missing piece of the puzzle had to do with these little nanomotors and how they operated. In fact, in 2016, 3 researchers were awarded the Nobel Prize in Chemistry for their work in creating a model that actually proved how these little protein structures in our body work. As a result, we are able to understand much more about this metabolic process and its relationship to our health and its relationship to the disease process in our body. The scientists at the Center for Deuterium Depletion have been studying this metabolic process for more than 20 years. And they've recently made some groundbreaking discoveries related to how this process is linked to serious diseases like cancer, chronic fatigue, diabetes, and others. But they've also discovered how this process can actually enhance athletic performance and, surprisingly enough, can even turn back the clock on aging. It sounds pretty amazing, right? And if you're thinking that this sounds too good to be true, hey, you know what? I'm with you. I'm a skeptic by nature, and I thought the same thing. But when you understand how it works, I think it will make sense to you too. Let me explain. It has a lot to do with deuterium. Deuterium is a substance found in nature. Now, it's relatively rare, but in recent years, scientists are noticing that exposure levels are going up and up and up as a result of conditions in our current environment. So what exactly is deuterium? It is heavy hydrogen. It's almost exactly like regular hydrogen, the hydrogen that our body uses in combination with oxygen inside those little nanomotors to make energy, but there is one very big difference. Hydrogen only has a proton in the nucleus, whereas deuterium has a neutron and a proton in the nucleus. And what this means is that it is twice as heavy and twice as large as normal hydrogen. Now here's the problem with deuterium in your body. It looks so similar to normal hydrogen that your little nanomotors are fooled into thinking that it's regular hydrogen until it gets stuck in the nanomotor. That's right, it's too big to pass through, so it breaks those delicate little motors that are made of proteins and renders them totally useless, unable to produce energy forevermore. But there's more bad news. Those heavy hydrogen don't break. They just keep going around to the other nanomotors, and then they break them too. So the more deuterium we accumulate in our system, the less able our body is to produce energy. Now, this can be a real problem, especially if your body is trying to fight disease. And to make matters worse, not only does deuterium act like a bull in a china shop when it comes to breaking your body's metabolism, it also goes around in your body masquerading as normal hydrogen. Now, this is important because it can unintentionally trick your body into using deuterium atoms to replace those three-dimensional structures that your body makes, like your liver, your kidneys, and your thyroid, perhaps setting the stage for autoimmune conditions. Now, our scientists at the Center for Deuterium Depletion have been studying deuterium and its relationship to the metabolic process in our body for years. They've discovered the devastating consequences that deuterium can have on the body, and they've also developed methods to test and reduce high levels of deuterium in your body so we can eliminate the risk of deuterium doing damage to your system. And there is good news. Our scientists have also discovered that once your deuterium levels reach below 130 parts per million, your body seems to take over and be able to actually naturally deplete deuterium on its own.